Thanks for the introduction, David. I'm Mark Pivac, CEO at FBR. Look, if you haven't realised it, Australia is in the middle of a housing crisis. And that, when I say we're in the middle of it, it's been around for a long time and we don't see it going away. One of the big issues is that in Australia, like many parts of the world, we rely on bricklaying. And one of the big issues there is that it's a fairly unattractive trade for young people. The age of masons is just generally increasing. Young people don't want to lay brick and block. And this has meant that markets have opened up to a lot of alternative materials. But brick and block really is one of the best ways to build a house. And that's not just in Australia, but also the US, Europe, all throughout Asia, around the world, in fact. So what FBR has done, could I have the next slide, please? So what our solution is Hadrian. And what this is a big robot which builds the walls. Its key features are quickly deployed, so it's truck mounted, it drives out to site. We can build the walls of a typical house in a day, as opposed to 2 to 6 weeks for a team of manual masons to do that job. It's a digital solution, and the jobs that it creates are digital and high-tech, robot operating machinery. We really get rid of all the heavy lifting. So it's now an attractive trade for people to look at getting involved in the construction industry. What we've really done is taking the automation that's typically seen in factories and figured out a way to get that out on site. Now, in doing that, we've created some really key technology, and the main core technology that we have is dynamic stabilization. And what that enables is really big robots to do really accurate jobs. And I'll get into some of the adjacencies and other applications of that in a little while. But having a really accurate house structure, it enhances not just the production of the walls, but the entire manufacturing process. So traditionally in manufacturing industries like car making and so on, everything is built off-site and it all comes together. And we know that in the factory, when you go to fit the doors, they're going to fit inside the door frame. When you go to fit the windscreen, it's going to fit inside the windscreen. Every single part on the car is interchangeable. Traditionally, a lot of that has not been the case for houses. You build the walls, the manual masons do a great job, but it's just not accurate to have everything else pre-manufactured. And there's a lot of measuring and fitting and on-site work to actually make things work. By having a really accurate structure, it enables parallel manufacture. So the enhancements to the building supply chain go way beyond Hadrian, and it's really up to builders to embrace this potential to really revolutionise their delivery of housing to the market. Next slide, please. So how it works, it's truck mounted. As I mentioned before, we have laser guidance. So what we do is we set up a laser tracker, and that tracks the end of the boom. You can imagine a boom which is long enough to build a house. It's about 32 metres long, can bounce around quite a bit as product moves through it, as the wind blows. And even just the inaccuracy of setting up the Hadrian itself on site, we don't have to set it up perfectly. The laser tracker takes care of all of that. We survey the concrete slab with that laser tracker, and then Hadrian builds in that coordinate system of the house and builds very accurately. So the house is actually defined by CAD definition off-site and ahead of time. CAD is computer-aided design. It's a very common software which is used to design all manner of products, including houses now. So the builders are familiar with that. And we have developed special software which imports that CAD design. We can quickly create the design in our software. And it figures out where every single brick goes in the house. We also work out where all the cut bricks need to be. And Hadrian can either take pre-cut bricks on the pallets, or we can fit a saw into Hadrian, which is also computer controlled, and Hadrian will cut the bricks and blocks to suit. Could I have the next slide, please? So our main tenets are that Hadrian is obviously a lot faster. It's also got the accuracy to enable parallel manufacture. There's a massive improvement in safety. You can see this building site here. There's no ladders, no scaffolding, very little waste around the building site. So all of those trip hazards, working at height hazards have all disappeared. All the manual handling hazards have gone. We handle as much as possible through machinery such as Hadrian itself, telehandlers handling full packs of bricks. One of the big things people don't realise is that there's two parts to this problem. Laying the bricks is probably the easiest physical part of the job, certainly the most skilled part. But the real laborious part is a typical house has about 80 tonnes of bricks, which at the moment are currently manually moved from wherever they're delivered, and they do try and deliver them close to where they're being used. But those 80 tonnes of bricks and blocks have to be moved by the bricklayers to where they're being laid. All of that delivery is automated with Hadrian. We also have massive waste reduction because we know where every single brick is going to be, and we can reuse off-cut bricks. There's quite a big waste reduction. Typically about 10% of the bricks in a building either over-ordered and wasted. We can cut that down to virtually zero. You put all those things together, the speed, the accuracy, the safety, and the waste reduction, and that obviously leads to a cost reduction. Next slide. Okay, so Hadrian can be used across quite a wide range of the construction industry. It was originally targeted for residential single family. Of course, we can do residential multifamily as well, small commercial structures and also infrastructure. Hadrian is not just limited to the reach of the boom. We can reposition Hadrian and make walls match up perfectly. We've done that in some of those larger structures like the one at the bottom right of the screen. This is a 16 townhouse development in Willagee, multi-storey, required multiple setups of Hadrian, and all of those walls matched up perfectly. Next slide, please. So we're at the point of commercialisation. We've done a lot of demonstration work. We've shown that the technology works. And across those demonstration projects, we've completed a lot of different kinds of structures. They were chosen not necessarily as best fit for Hadrian, but to show the diversity of the technology. We built 5 houses. That's one on the bottom left in Wellard, which is a typical suburban build in Western Australia. New subdivision went in. We built 5 houses in a road down one side of the street while manual builders built other houses on the other sides of the street. And the speed difference was really striking. With Hadrian at that time, we would come in and build a house in 2 or 3 days, get the walls up, and on the other side of the street, the bricklayers may have only got around to chalking out the slab and perhaps standing up 1 or 2 door frames. We've also built a childcare centre, commercial townhouses, 8-storey townhouses, and we also deployed over to the US and did a 10-house demonstration in Fort Myers in Florida. They have a lot of Besser block building over there. It's all cyclone or hurricane rated, and we actually built while there were cyclone or hurricanes in the region. And we've recently signed an MOU for a Hadrian sale to a Northern Territory builder for 7.8 million, and another sale to a New South Wales builder. So we're just working through the details of those contracts now, and we'll update the market as appropriate. Next slide, please. So as I mentioned earlier, our core technology is DST, or dynamic stabilisation, and this has a number of different use cases, particularly anywhere where you need to use large robots. Typical industrial robots work up to a reach of perhaps 3 metres at the very most. 1.5 metres is much more typical. Our dynamic stabilisation technology enables us to build accurate robots which can reach basically unlimited. As I mentioned before, we've built Hadrian already, which reaches out 32 metres. And in Western Australia and also Korea, we've identified a market for an 8 metre reach welding robot. And this is our next product, which is called Mantis. And it has applications across shipbuilding, heavy fabrication, and large-scale metal printing. We've just launched that product ahead of actually having a physical one. And we're in the process of building those first prototypes. We've got an excellent potential sales pipeline with a lot of customers lined up just waiting to see the actual physical demonstration of those Mantis robots. Next slide, please. So I mentioned South Korea and Samsung Heavy Industries. We've been working with Samsung Heavy Industries. We have an engineering services agreement in place, and they approached us. It wasn't the other way around. They approached us because they'd seen DST. They build, as you can imagine, very large ships, things like LNG carriers, floating offshore oil and gas ships, container ships, bulk carriers, that sort of thing. This shipyard here employs 25,000 people plus about another 15,000 contractors on site. And a huge amount of the shipping industry is welding and also complex fit out. So they approached us with that they have a mandate to really automate their processes, and they approached us to see if we could help them. They thought the DST would be very applicable, and it is. Our first phase was to do something to demonstrate to them that we could actually automate this particular process, which they were interested in. It's not related to DST, but it was very important that worked. We've done that. We've demonstrated that. They've been down and visited it. I was up in Korea last week, and we're just working through the next phases of work now. So, as I mentioned, phase one's been delivered, where we conducted a physical demonstration and validated that, and we've submitted that, and we're just waiting on their final sign-off on that. And my trip last week was in relation to the next phases of work, and as those turn into contracts, we'll update the market on those things. Next slide, please. So here's a corporate snapshot. We think FBR represents some pretty good opportunity at the moment. You'll see earlier in the year, we had a much higher market capitalisation. We had a bit of a misstart with the launch in the US, the change of government there, change in economics. We still have a Hadrian in the US off the back of that demonstration program, and we're working through a lot of potential opportunity over there, but really just waiting in the wings for their economy to improve over there. Here in Australia, we see a really good future. The government has typically tried to solve the housing crisis by stimulating demand. We're now seeing that they're starting to stimulate supply. For example, the West Australian government has just recently launched a $50 million housing innovation fund, a mix of grants and loans, and we'll be applying for that along with some builders who are very interested in introducing Hadrian technology into the WA market on a commercial basis. So off the back of that, I'll hand it over for questions. Thank you, David.
Thanks, Mark. Great presentation, and a company I've certainly watched with interest as Hadrian has developed. A couple of questions have come through, so we'll jump straight to them. What are the key steps towards converting the existing MOUs for Hadrian sales into full commercial deployments?
Yeah, so look, it's a really good question. As you know, an MOU outlines what the parties intend to do, and the commercial contracts with a $7.8 million piece of equipment cover off on all of the details. So we're going through those negotiation phases. It's also contingent on those potential clients gaining finance. We're working with them on that and also engaging with finance companies as required. It may involve some of those potential customers forming partnerships just to expand the scope of work and to get things financed and underway. So we're working through those things. The building industry is very busy at the moment. So getting the attention and getting things devoted to the change management that's needed are some of the challenges which we're facing, but we're quite confident that we'll work through those in the near future.
And how do the DST and Mantis platforms position FBR in broader global automation markets?
Yeah, so look, it's a massive market. We've also about to launch another product, which we'll call Firehawk, which is for laying refractory bricks in the steel industry. There's about 1,000 steel mills around the world which are just continually laying refractory bricks to reline their steel ladles. So that's one aspect. Obviously, there's an immense amount of heavy fabrication done around the world, and there's not really an off-the-shelf robot available for that. We see that as massive markets. On our website, we have some fantastic presentations on Mantis and DST and also Hadrian. And just to give you an idea of the scale of the problem, the Australian Welding Institute estimates that there's about 78,000 welders shortage just in Australia alone. And around the world, it's millions. So, the way to solve some of those issues, obviously training more people, but automation and robotics is really kicking off. There's a lot of interest in small cobots in the fabrication industry, but there's a lot of issues with moving those around the plant, and that's where Mantis comes in. So between Mantis, Hadrian, and Firehawk, we have total addressable markets that are absolutely massive.
On that note, Mark, thanks for the presentation, and we look forward to following with you and the company with interest.
Thank you, David.
Thank you.